So let's use the rules of thumb that we've discussed just a moment ago to try to actually calculate a cooking time. So this table that I've made here sort of gives recommended cooking times for cooking a turkey. So these are turkey cooking times that I found in some cookbook. And so let's actually try to see if our rules of thumb are able to reproduce these times. So in particular, why don't we look at this one? Let's just look at the smallest size turkey, the one that is 8 to 12 pounds, and the cookbook recommends that we cook that for 2 3/4 hours. And let's see if we can compute that using what we said. So remember what I told you. So let's see how this goes. So what I told you was that what we need to do is we need to say that the cooking time, T cook, is equal to L squared over 4D, where, since this is a turkey, what we should do is take L to be the radius of the turkey. So we're going to take L to be the radius of the turkey. So how do we compute the radius of the turkey? Well, what we do is we say that we approximate, as we've discussed before, that the turkey is a sphere. And if the turkey is a sphere, we say that the mass of the turkey is its density, rho, times the volume of a sphere, which is 4/3 pi L cubed. So that would be the mass of the turkey. And we've been given the mass of the turkey. And the mass of the turkey that we're given is 8 pounds. So let's just take the lower end of the weight in the range that we're in. And 8 pounds turns out to be the same as about 3.9 kilograms. So if you convert that, that's 3.9 kilograms. And so from this equation, which I will just circle so you sort of all realize which equation that I'm talking about, from this equation we can compute the radius, we can compute L, the radius of the turkey. Now let me just erase a little bit so that we have more space in order to do this calculation. So I'm going to erase all of that. So the only question really is, well, what do we use for rho? So what is it that we use for rho in doing this? And so for rho, what I would recommend using is it's the density of turkey, but turkey is of course basically water. So let's take rho to be about 1 gram per cubic centimeter, which is the density of water. And if we do that, we of course have to convert kilograms to grams. So down here when it says 3.9 kilograms, then what that becomes is 3,000, so 900 grams. So this is grams now, and now basically we can solve for L, and if you do that, you just have to solve this equation for L. So all of this implies, I'm going to change my color ink to basically emphasize the gravity of the moment, so all of this implies that L is about 9.6 centimeters. Okay, so that is the L that corresponds to a spherical turkey with a weight of 8 pounds. Okay, so now that we've calculated L, the radius, to be 9.6 centimeters, we can use our wonderful formula for the cooking time. T cook is equal to L squared over 4D. And that will give us the cooking time. And so what that is 9.6 centimeters squared over 4. And for D, as always, we use the heat diffusion constant of water, since the heat in a turkey, when you cook it, travels through water. So that's 1.4 times 10 to the minus 3 centimeters squared per second. And if you multiply all this out, then what I find anyway is that this is 16,457 seconds. And what we'd like to do is compare this to the cooking time that was reported on the recipe, which you will remember was about 2.75 hours. So now let's see. So to convert this, we have to convert from seconds to hours, and we know that 1 hour is 3,600 seconds. So this then corresponds to be about 4.57 hours. So that's actually quite a bit longer. It's almost 2 hours longer. So if we compare that, so to the cooking time, that's about 2 hours. So compare this to CF, 2.75 hours, 2.75 hours, which was the cooking time. So this is about 2 hours longer than the cooking time. So it's giving us a number which is in the right ballpark, but it's a bit larger. And so now actually I want you to stop and think about why. So this time that we've calculated is the characteristic time that it takes for heat to travel across the turkey. But what it doesn't account for at all is how well you've cooked the turkey. That is the turkey overdone or underdone? That is, what is the temperature that you're trying to reach? So and in order to do that, we have to do a bit more of a precise calculation, which actually involves okay, so the reason the cooking time was off, so the problem that we have to solve, is that our calculation for the cooking time ignores our calculation ignores temperature. I have to spell ignores temperature. It ignores the temperature scales. And we know that the temperature scales matter. I mean, you know that if you want to cook an overcooked turkey, it takes longer than an undercooked turkey, even though the orders of magnitude are the same. I mean, both an overcooked and an undercooked turkey take of order 4 hours, actually, for the weight that we're deciding. But in order to get it right and to really get it to come out well done, which is what you're trying to do when you use a cooking table, you have to be a little bit more precise than that and take into account the typical temperatures. And there are really two ways to get around this problem. One is to do a more precise calculation using the type of software that the MIT students put together. And that's certainly one thing that one could imagine doing, but that's a little bit complicated, and you don't want to always have to be running and using computer programs when you're trying to cook in your kitchen. So a second way to do it is to actually use what we've told you about the time dependence of the temperature. And so I just want to remind you of the equation that we showed you. We told you that the temperature as a function of time when you're cooking is given by the following formula. So it's the external temperature, that is the temperature of the oven, T external, plus T initial, that is whatever the initial temperature was before you put it in the oven, minus T external, times, and I'm going to write this on the line below, times e to the minus t over tau, where tau is a characteristic cooking time, where tau is the characteristic time. Now, this is an equation which involves all of the things that we've been talking about. It involves the external temperature, the temperature of the oven. It involves the initial temperature, the temperature that you put the turkey in, and it involves tau. Now, this tau is actually the quantity that we've been just computing. So this tau is actually L squared over 4D. And so I hope you can see that this equation has within it the other factors that you just know from your common experience matter when you cook, namely the temperature of the oven, the initial temperature. I mean, it takes longer to cook a turkey if it's frozen than it does if it's not frozen. That should be in there someplace. And somehow by using this, we should be able to get a better formula for the cooking time. So how do we do that? Well, so as you know, what you do when you cook a turkey or when you cook anything, is that you cook until this temperature, the temperature at time t, is equal to some target temperature. And when it's equal to a target, then that is when you declare the turkey to be cooked. So now what I can do, and I'm going to rewrite this, I will try to write this neatly. So so the turkey is cooked when the temperature at time t is equal to the target temperature. Let me just call that T star. And that is equal to T initial, which I'm going to just call T init, minus T external times e to the minus t over tau plus t external. And now what I can do is solve this equation for t, for the time. So I need to solve this equation for the time that the turkey is cooked. So here I'm going to circle the time that I have to solve for. So how do I do that? Well, this is just a little bit of mathematics. So now what I'm going to do is subtract t external from both sides. So if I write this as t star minus t external, and then that is equal to T init minus T external times e to the minus T over tau. And if I now divide both sides by this factor, T init minus T external, I have the T star minus T external over T init minus T external is equal to e to the minus T over tau. And now I can basically take this equation and I can actually solve it for t. And so when I do that, I get the cooking time, t cook, which is equal to tau. And I'm going to just write that tau is L squared over 4D, because that's what we've said, times the logarithm of, and this is the logarithm based e, of T init minus T external over T target, the target temperature, minus T external. Okay, and this equation, actually, you'll notice, says that the cooking time that we started with, the one that we actually spent our time computing before, namely this L squared over 4D, that was the time that you'll remember we think of as being 4.6 hours. So this was 4.6 hours. Then we multiply it by this factor inside of the logarithm. And so now basically what we have to do is understand what that factor is, and once we do that, then we can actually calculate the cooking. So now it turns out that the recipe that I showed you had an oven temperature. I didn't actually tell you the oven temperature before because I didn't need to. So the external temperature was 325 degrees Fahrenheit. The target temperature, and actually 325 degrees Fahrenheit is about 163 degrees Celsius. So the target temperature for a turkey, T star, is about 73 degrees Celsius. The initial temperature, I don't know, the initial temperature can really be whatever you want it to be, I suppose. The initial temperature, T init, but if it's room temperature, it's about 23 degrees Celsius. So if we then sort of use this, so the difference between the external temperature and the initial temperature, that's about, so the numerator here is about 140, and the denominator, that's basically T external minus 73, and that is, let's see, that is about 90. So this is the logarithm of 140 over 90. And it turns out that this factor is about 0.44. So that's what this factor is. So what we need to do, actually, is multiply 4.6 hours, which is what we had before, by 0.44. And here, let me try to erase a bit so that this will end up being dramatic. So I'm going to erase. If I can get this thing to erase, I'm going to erase. Actually, no, it won't let me erase. So I was going to erase. Here, I'll put this all in a red box instead so you can see, because this is really the critical calculation, is that our cooking time is actually 0.46 hours times 4.6 hours times 4.44, and that number turns out to be about 2.03 hours. And so that actually is closer to what we had before. To the cooking time. The cooking time said 2.75 hours, and now when we take into account this correction, we get a cooking time of about 2.03 hours, and that's closer. It's still not perfect because we're not exactly solving for the diffusion of heat in the turkey, but it's giving us a much better idea of the cooking time. And so the point of all of these rules of thumb is to just convince you that you really can calculate cooking times by basically using these sorts of things. You can understand why recipes take the time that they do, and it can be a useful rule of thumb when you think through the temperature dependencies of cooking.